Okay, so happy GIS Day, everyone. Welcome to my presentation and thank you for joining me. My name is Amanda Patton and today I'm going to be talking about the parcel fabric and how we used it to comply with New Jersey tax map submission standards. First, I'll tell you a little bit more about myself. I'm a GIS technician at Mazer Consulting. I have over 3 years experience in GIS data creation and design, with an emphasis on land records and creating tax maps. My expertise include creating and maintaining GIS geodatabases, managing parcel data, creating tax maps, and managing replicated databases for multi-user editing. I have bachelor degrees in Geographic Information Systems, Planning, and Geography, all from Rowan University. So a little background on tax maps. Property taxation in the US dates back to the original Pilgrims at Plymouth, Massachusetts. They created laws regarding taxes and assessments of a fort that they built. The first tax mapping originated in the 1670s in Boston, and it listed assets and values. Tax maps used to be hand-drawn on linen, and then this later progressed into mylar. Both of these have the risk in decline in durability and readability because they could rip or smudge very easily. There was also the risk of human error, as they were drawn by hand in the field, so this could skew the courses. They also took up a lot of space, having to keep all the copies and revisions in paper form. The New Jersey Division of Taxation has very prescriptive standards, so much so that they have a manual of standards that is very specific. It outlines the line thickness, text sizes, and how things should appear in various situations, such as condos, paper streets, vacated streets, water bodies, easements, and others. But the Book of Standards keeps consistency between the tax maps of all 565 of the New Jersey municipalities. Tax map submissions are usually CAD submissions. Tax maps in New Jersey were typically prepared using CAD software. But we are using GIS technology to meet the state requirements while also updating the land records, which were out of date. Having the parcels in GIS will make the process of maintaining these records so much easier. The tax maps were created for the city of Elizabeth, New Jersey. Elizabeth is one of the largest cities in New Jersey. It has almost 130,000 people and covers almost 13.5 square miles. The final tax map included almost 20,000 parcels and 234 tax map sheets. Elizabeth is a very diverse city, and it has everything from small streets to industrial facilities, retail and commercial areas, parks, highways, railroads, the Elizabeth River, the port, and an airport. The top left is an image of the 1930 set of tax maps, and the top right is an aerial view of the airport and port of Elizabeth. The landscape of New Jersey is ever-changing, and there's new development everywhere you look. So keeping accurate property records is essential. It is important to maintain these tax maps with as much accuracy and consistency as possible so that property owners can be properly taxed. Using GIS for tax maps is a relatively new concept, but there are a lot of benefits that come with it. The first one I'll mention is accuracy. They're not hand-drawn, so you don't have to worry about the risks associated with that. Another is practicality. They're stored digitally, printed when necessary, and therefore take up less physical space. And they create a seamless parcel dataset for an entire town. You can use attributes to keep information about the parcel, and you can then use that information to search for parcels, and you can link it to other databases. Since it's in GIS, we have it georeferenced, so you can turn on an aerial and see what is there, or you can add other data to your map to see how it relates to your parcels. Using GIS allowed for us to use version databases, which allows multiple simultaneous editors. Having land records in GIS lends itself to current web GIS as well, such as asset management. overview of the parcel fabric. It is made up of points, lines, and polygons, and it is a continuous surface of connected parcels or a parcel network. The left picture is what the parcel fabric looks like in your table of contents. You'll notice that we were using ArcMap instead of ArcPro. This was because when we started this project in late 2017, the parcel fabric tools in ArcGIS Pro were not fully rolled out yet. Some of the benefits to the parcel fabric are that it offers a way to maintain a seamless surface of connected parcels in one dataset. So there are no gaps or spaces, and it has a more accurate scale. Another benefit is the historic parcels. As lots are consolidated or subdivided, the original lot is given an end date and is stored within a historic parcel layer of the parcel fabric. This allows us to see what an area was like before a major subdivision or other change. When redevelopment is always occurring, this is an important tool. In the image on the right, you can see that the red hatched area is now a historic lot because it was subdivided into 2 new lots. The parcel fabric also allows us to relate each parcel to a plan, which is the legal recorded document that describes the parcel. It stores this information in the plan directory. When documents containing specified survey points are available, they can be used as control points in the parcel fabric to build parcels around that specified known point. Control points are defined by X and Y coordinates. They are more accurate than the parcel fabric points, and for that reason, they may not always match the parcel fabric point. Adding more control points will continually improve the positional accuracy of the tax parcels throughout the city. Using these points incrementally across the city can help improve the accuracy of the entire dataset. Our workflow was developed with Esri, and it consisted of some preliminary drafting and georeferencing of the tax map, which was completed in CAD. And then the raw CAD data was migrated to GIS, cleaned up, and converted to polygons. GIS attributes were then populated, and the data was polished. Some of the attributes that we included were blocks, lots, and sheet numbers. All of this was prior to preparing the individual tax map sheets. The left image is showing some of the important attributes of a parcel that is selected. Some of the software that we used includes ArcGIS Test Desktop, Enterprise GIS, AutoCAD, Civil 3D, Nearmap, and ViewWorks. Here are some of the main geoprocessing tools that we used during this project. I'm only going to get into the details on a few of them, but feel free to contact me if you have any questions or want more info about the others. We used feature to feature class to get lines from CAD to GIS. We used a feature to point to get the annotation from CAD to GIS and then use it as attributes for the parcels. Topology rules were used to clean up the lines and ensure that they closed so that we could create polygons. And spatial joins were used to help us assign the block number to the parcels. The City of Elizabeth was hand-drawing updates to a 1930 set of tax maps. There were about 30 years of updates that needed to be made from when the CAD tax maps were created. The old 1930 set of tax maps had different block and lot numbers than the CAD set, and the city wanted to update their parcels and tax assessment database so that they had the same numbers from the CAD set. This required creating a cross-reference database of the old and new numbers in the tax assessment database. Properties that required updates had to be located by comparing the 2 tax map sets, and then the edits were applied to the new parcels that we were creating in GIS. Edits were made to the parcel fabric based on filed deeds. Numerous updates and edits needed to be made to the parcels, so it made sense that multiple people would work on them to get them done in a timely manner. We used versioning of an SDE database and replication to allow for multiple editors. The image on the left shows an example of what our version database could look like. There were several different types of edits that needed to be made to the parcels. One being subdivisions. So in that case, we would use construct from parent, and from there we would add a parallel offset or a break line, depending on if the subdivision was simple or complex. Sometimes there were consolidations in which we would merge 2 or more parcels together. Sometimes the CAD line work was inaccurate, and we would have to transform the parcels. In this case, we could take one of the points, like a vertice, and adjust it, and this would in turn move the parcel line that shared that vertice. This is how the seamless parcel network is maintained throughout the parcel fabric. In the case of completely new areas, we would have to create a new parcel. The image on the left is showing how some of the editing tools are accessed in the parcel fabric. If you right-click, you can see the construct from parent and merge options. If you wanted to access the transform and new parcel options, you can use the parcel fabric editing toolbar. And the image on the right shows a list of some types of tax map updates that we had to perform during this project. Creating the tax map sheets. The image here is of a tax map sheet that I created for the city of Elizabeth. This is what the final sheets look like. Each sheet has its own MXD. There are 234 sheets, plus an index sheet and 6 key sheets. New Jersey has a unique requirement for how tax maps need to be displayed based on block limits, such as right-of-way lines, where the rest of the world uses a grid form. In the image shown here on the bottom of the sheet, there are lots that continue in each of these blocks, but they aren't shown on this sheet. They're shown on the connecting sheet. You can't have duplicate parcels on separate sheets, so you have to pick which sheet they're going to be shown on. Definition queries were used to ensure that we were only showing those parcels that were necessary on each sheet and prevent showing the same lot on duplicate sheets, which would not be in compliance of division standards. Without attributes, definition querying would not be possible. Sheet boundaries were created to clip the extent of what would be shown in the data frame and provide a buffer between where the lines of the data end and where the sheet border is. Python scripting was used to create PDFs of all the MXDs without having to individually open each document and export it to a PDF. We faced a number of project challenges that we had to overcome throughout this process. One was that we cannot display a full grid map, so attributes and definition queries were used to limit the data that was shown on each sheet. Another was the updating of the block and lot numbers. They have changed since the 1930s, and they switched over to a new numbering system, and these had to match up to the block and lot numbers that were in the tax assessment database. So we had to create a cross-reference database between the two. There's also a lot of properties that weren't identified up to state standards, but the attributes and cross-reference list helped us identify these missing properties. We were able to join the tables and find properties that didn't have matches. Your list of parcels needs to match your tax assessment database. Using GIS helped us to clean up their assessment database. It allowed us to assist the city's tax assessor with identifying and resolving any issues that may have existed in the tax assessment database. This was a very large job, and there was a lot of work to do on a tight timeline. We used versioning to allow for multiple editors to speed up the process. Some other benefits to using GIS for tax maps is that you can then use that GIS data that we created in other ways. You can use joins to link the parcel data to the tax assessment database, which contains owner information, property information, tax information, and other things. You can overlay other data, such as flood data. The flood hazard lines actually need to be on the tax map, so that was very beneficial in our case. You can also overlay data for other purposes not related to tax maps, such as wetlands data, zoning data, voting districts. Having the parcels in GIS will now allow us to use them for asset management, such as property upkeep, through ArcGIS Online, Survey 123, operations dashboard, or others. We have the data served into ViewWorks, which is an Esri partner that offers off-the-shelf EGIS asset management programs that the city is currently being trained on by our staff to access their tax map data. GIS should be the new and improved standard for creating tax maps. Now, before I actually end this, I just want to reiterate that all of this was done in ArcMap. At the Esri User Conference, I got the chance to attend several Parcel Fabric presentations, all of which focused on the Parcel Fabric in Pro. So now I just would like to share why I'm excited to hopefully be able to use the Parcel Fabric in Pro, like I did for the city of Elizabeth with another town. The Parcel Fabric is now fully supported in Pro. When we started this project in 2017, it wasn't yet, so that's why ArcMap was used. The Parcel Fabric in Pro utilizes record-driven workflows. So when you make an edit, you create a record to store all the information associated with that record, including all of the parcels that are involved in the edit that you were making. You can go back into your records to see the parcels that were involved. The record name is stored in the parcels as well. Each parcel can have a record that created it and a record that retired it if it is a historic parcel. I feel like this is so helpful for the organizational purposes, and it will also help people to be able to understand what happened in a certain location over the years. There seem to be some updated ways to perform edits in the Parcel Fabric in Pro, and other ways to maintain data, and all of these seem to be very user-friendly and easy to use, so I'm excited to get a chance to use those. There are a number of workflows in Pro that can be utilized to automate frequent processes, and these can be personalized to meet the needs of your specific project. You can have multiple parcel types in your Parcel Fabric, and each can have their own attribute fields and topology rules. And this will be useful for when you have tax lots, blocks, easements, municipal boundaries, and any other boundaries that you may have. These are just a few that I immediately thought of based on my tax map project. There is built-in quality management, so the topology is incorporated so it can be viewed as you edit, so all of the errors that you may have don't pile up. You can fix them as you go. Esri also introduced branch versioning for the Parcel Fabric in Pro. And this allows the Parcel Fabric to be added to the web through Portal, so people outside of the company or network can view or edit it easily. With branch versioning, you also do not have to periodically compress, rebuild indexes, and analyze data sets, like I had to do while working on the City of Elizabeth project. And the ability to be able to draw by meets and bounds is very exciting and simple to use. I've actually used this function in the Parcel Fabric in Pro for a different project. We needed to draw the easements on parcels based on a deed that contained meets and bounds description. We already had the GIS parcels, so I simply loaded the parcels to Parcel Fabric, created a new parcel type for the easements, and began creating the records and drawing easements using the traverse tool and the parcel as a reference for the starting point on the deed. If you couldn't tell, the Parcel Fabric makes me pretty excited, and it's been really fun talking to you guys about it, so thank you for listening. If you have any questions, you can ask them now, or you can email me. My email is on the screen.